Rene Descartes was a French-born philosopher and mathematician and lived between the years 1596 and 1650. He's been dubbed the father of modern philosophy and has written a book called The Meditations on First Philosophy, which is still used in college philosophy classes. He's big time in the math world as well. And, overall, he's, the math Hall of Famer type kind of, that kind of level, if not more. And he's been credited with creating the Cartesian coordinate system, and that's the one that we do our graphs on. He's been called the father of analytical geometry, and he's also been crucial in infinitesimal calculus as well as analysis. So this guy is one of the biggest mathematicians ever to live. And we're going to talk about his rule of signs. So Descartes' rule of signs says that the number of positive real zeros of a polynomial f of x is equal to the number of sign changes of the coefficients of f of x, or is less than this number by an even number. And the number of negative real zeros is equal to the number of sign changes of the coefficients of f of negative x, or is less than this number by an even number. Okay, and this is a very simple thing to do, and it might sound a little bit confusing, but it's very, very simple. And the whole idea of this is, again, we're trying to narrow down our options of where these zeros lie, and so that we can find them a lot easier. Okay, so remember, we're looking for sign changes here. And for the positive real zeros, we don't have to do anything. We just look at the function as given. Okay, and we start off here positive, and now we change to a negative right here. So there's one sign change. We move along, we're at negative, and we go to positive, so there's a second sign change. And then finally we go from positive to negative, so a third sign change. So that tells us by Descartes' rule of signs that f of x has either 3 or, and what you do is it says in the theorem or in the rule that less than that number by an even number. So you just take whatever you get, 3 in this case, and start subtracting 2 until you get to 1 or 0. Okay, so it's 3 or 1 positive real zeros. So we also want to look to see how many possible negative real zeros there are. And to do that, we're going to substitute into f of x negative x. Okay, now this sounds like it's going to be a big pain, but it's pretty simple. Okay, and I'll kind of write it out on this first example, and then we'll talk about why I think it's pretty easy. Okay, so we're going to simplify this, and what you should remember is that any negative raised to an even power becomes positive, and any negative raised to an odd power is still negative. And so this would give us x to the fourth minus x cubed minus 2x minus 2x squared, sorry, minus 3x minus 4. Okay, so this, had an even, this term had an even exponent, so it's always going to be positive. This one had an odd, so it switches to negative. Okay, this one had an even, so this part is positive, but it doesn't affect that, so that stays negative. This term becomes negative, and this one stays negative. So now we're just going to count the sign changes again. So positive to negative is 1, and then you see that it stays negative the whole way. So we can say that there is 1, and we're supposed to subtract by 2, but then we're in negative and negative areas, and that makes no sense. So there's going to be 1 negative real 0. Okay, so let's do one more example of applying Descartes' rule of signs here. So we're just counting how many times the signs change as we run across the polynomial here. We start out with a positive, and we go to a negative, so there's one sign change. It stays negative, but now we go from a negative to a positive, so there's two sign changes. So that means that there is either 2 or maybe none, 2 or 0 positive real zeros. Okay, so now we want to check f of negative x. Okay, and I'm just going to do this all at once because hopefully you understand that you're really just checking for even and odd exponents. Okay, so when we plug in negative x into the first term, it's going to give us negative out. So then, and that's because, again, because a negative raised to an odd power is going to stay negative. So this one's going to be negative 2x cubed. When we plug in a negative here and square it, becomes positive, so that doesn't change here. So then we're going to have negative 7x squared. We plug a negative in here. Negative 5 times negative x is positive 5x, so plus 5x plus 4. Okay, and again, we're going to count the sign changes. We're all negative, then we become positive, so there's one sign change. And then it stays positive. So one sign change means that there is one, possibly one, negative real 0.